I'm Anil Kumar, and before we begin with rational functions, it is kind of important to get ready for it. Most important thing which you need to review is factoring skills. So we will actually take a few examples and review the factoring skills. Let's begin with simple common factoring example, which is kind of like 6x minus 9y. Now to factor means to write sum or difference form into product form. We could always see what is common between the numbers and the variables. Now nothing is common between the variables, but the numbers 6 and 9 have a common factor of 3. So we could take 3 as a common factor. Dividing 6x by 3, you get 2x. Dividing 9y by 3, you get 3y. So we could write this, that is the product form, correct? So that is how we factor. Let me take a few typical examples. We have worked with difference of squares. Let us say x squared minus 16. Now here this is a difference of square and it could be factored as x plus 4 times x minus 4. The reason is that I could write 16 as 4 square. So what I really am looking at is kind of like this. Let me rewrite this. X square minus 4 square. So it is difference of squares. I could write this as product of sum and difference, right? So that is another example. So we have done two examples where we have considered kind of group factoring and factoring by difference of squares. At times we could have combination of these, right? So let me give you a combination this time. So combination really means that something like this. Let us say we have 2x squared minus let us say 18, right? So if I write 2x squared minus 18, it is not a difference of square, but we could have 2 as a common factor. So let's factor out 2 first. Then we get x squared minus 9, and now it becomes difference of square. We could write 9 as 3 square, that is to say 2 times x squared minus 3 square, right? So that is clearly the difference of square. So we get our answer as x times 2 times x plus 3 times x minus 3. So now we have written that difference as product of these three factors. 2, x plus 3 and x minus 3 are the three factors for us, right? I hope that helps. So in this case, most of the things which we have taken are all binomials, right? So we began with 2 terms. Okay. Now let us take 3 terms or trinomials and see how to factor trinomials. In trinomials, you consider 2 different cases. One was where the leading coefficient is 1. So let me take an example of that first. Let us say x squared plus 7x plus 10 be our example. Now for trinomials, we are looking for 2 numbers whose product will be this number, right? So we are saying what are the 2 numbers p and q which when multiplied gives you 10, and when you add them up you get 7. So 10 you can get by 10 times 1 or 5 times 2. 5 times 2 is what we'll work with, since when you add them you get 7, right? So that's the whole idea. So these are the 2 numbers, 5 times 2. So we could split 7 into these 2 numbers and factor this as x plus 5 times x plus 2, right? So when you expand, you will get the trinomial we started with, right? So these are simple trinomials where leading coefficient is 1. At times, you may have a leading coefficient which is not 1. Then how to factor? So let me take another example to factor those kinds. So what I'll do is I'll write some number here. So we'll have 6x squared plus, let us say, 7x plus 2, right? Now in this case, clearly product of 2 numbers should be 6 times 2, 12. So we are looking now for product of 12 and sum again for 7, right? This is what we are looking for. You could get this by 4 and 3, right? So 4 and 3 are good numbers, right? So now we will split 7x. We could write this as 6x squared plus 4x plus 3x plus 2, and now we do group factoring. What is common between these two? 2x. We could write this as 3x plus 2, and here we already have 3x plus 2. Now we'll do group factoring again, taking 3x plus 2 as common, left with 2x plus 1. So that is the factored form in which 3x squared plus 7x plus 2 can be written, right? So that is how you do factoring when we have a trinomial where the leading coefficient is not 1. So in this exercise, what we have learned is how to factor using groups, how to factor when we have difference of squares, and this was combination of both. Then we did trinomial where leading coefficient is 1, and then we did trinomial where leading coefficient is not 1, right? So I hope with this you have understood the concepts, and now to practice, let me give you some questions, right? So your questions could be, you can factor if possible. Let me say factor if possible. Why am I saying so? At times there may be trinomials or binomials or polynomials which cannot be factored, right? So it is not necessary that always you will have a result, right? So let us take some examples as 2x squared minus, let us say 50, right? So this is one of the questions for you where you may employ technique like we did here, right? So let me add one more here. Let us say we have x squared minus, this time in between I took positive here, 2x, and let me write down some number here which will give you, let us say we have a term like 5, right? See whether this can be factored or not, right? So sometimes you cannot factor, so that is also a case, right? Now let me write down another question here which will be x squared minus 7x plus 10. So I'm changing this question, instead of plus I'm using minus 7. See if it works for you, right? So that could be another example, and we could have examples like x minus 1 whole square times 3 times x minus 1, right? Try to see if you could factor such an equation. So let these be your test questions, right, to practice. Okay, the last one here is 4x squared plus 48x plus 144, right? Let this be the last question for you. Well, at times, let me do this for you. We could have a perfect square or a trinomial with a perfect square, right? So here, let me show you factoring of this particular trinomial. I didn't consider it earlier. 4x squared could be seen as 2x whole square. 144 you could write as 12 square. The center term is 2 times 12, which is 24, times 2x, 48x. If you get that, then you know how to factor. Yes, it is. It is a perfect square. It could be written as 2x plus 12 whole square, right? So that is how you could factor that one, correct? So what we basically utilized here with our knowledge, we could write a formula. A plus b whole square is a square plus 2ab plus b square. At times we could have minus here, right? In that case this will be minus, and the formula being used will be a minus b whole square as a square minus 2ab plus b square. We also learned that if we have a square minus b square, it could be factored as a plus b times a minus b, right? So these are two formulas which we normally use for factoring, right? So you could apply those and then work out some of the such examples from your book. I hope with this kind of review you have got on rational functions will help you to solve or simplify most of the rational functions. I hope that helps. Thank you and all the best.